Okay, we have a water jet, cross-sectional area A, density rho, traveling at speed v. It strikes the wall, and the question says that after striking the wall, the water drops down vertically. So the key is to know that after striking the wall, the velocity drops to 0. So the velocity started as v and ended up as 0 upon striking the wall. To calculate the force exerted by the jet on the wall, we know that it's going to involve this expression here. Force is the change in momentum divided by the time taken for this change to happen. This came from Newton's second law. Force is the rate of change of momentum. So average force is delta P over delta T. Okay, so let's come back to this diagram here. If the water jet is traveling at speed v, then the distance traveled by the jet in duration time delta t would be v delta t, right? Speed times time, so that's the distance. So if this is v times delta t, then it means the water jet that started out at this position, after a time duration of delta t, it would have arrived at here, right? Which means in this duration of time delta t, we would have this tube of water hitting the wall. This is the amount of water that hits the wall in the duration of time delta t. Alright, so let's try to make use of that information in this equation here. So the amount of change in momentum occurs for this amount of water. So the volume of this cylindrical volume of water here would be the cross-sectional area multiplied by the length of the cylinder, which is V delta T. So this is the volume of this cylindrical volume of water. If this is the volume, then if we multiply it with the density, we'll get the mass. So this is the mass of water that hits the wall every delta T, right? And the amount of momentum change that occurred to this amount of water would be mass times the change in velocity, which is 0 minus v. Alright? And of course, the denominator here is delta t. So basically, this term here is the mass of water hitting the wall in duration time delta t, and because the velocity changed from v to 0, so this represents the change in momentum that occurs every delta t, and this will give us the expression. The delta t is cancelled away, so what we have is negative rho a v square. Alright. You should realize that what we calculated was the change in momentum of the water. So what we calculated is actually the average force that the wall exerts on the water jet. So by Newton's third law, the force that the water jet exerts on the wall will be equal but opposite in direction. So the magnitude will be rho a v square, acting in the rightward direction. Okay.